Hey, Dan, can you hear me?
Yes. Hello, Cheryl. Good morning.
Hey, good. I really need Amy to keep me on track, okay? So
Uh,
sorry that very last minute.
that's okay. Thanks. I just ran through those slides you have. That's awesome information. As I described, there's basically numerous audiences where I can go with this info. When we have these quick calls, we've done a few, as I mentioned, over the last couple of weeks. The sort of the ideas pop up quick, as well as often the scientists as speakers are telling me, here's who else should know about this, and I'm compelled to make sure it gets into the right hands.
That's great. Last, let's see, November 6th or something, it was a Friday, Senator Moran was here.
Oh.
And he is the chairman of the Senate Appropriations Committee for Science.
For science, yes.
Yeah, he's out of Kansas. So he was visiting us that day. And so a lot of DC politicals and headquarters staff were here during that visit. So just thought I'd let you know.
Great. Okay, that's good to know. That is a general realm of additional activity that I'm always interested to grow more into and get reports into those hands, not just of our Colorado delegation, but any of those appropriate congresspeople or senators in different committees. If I can be helpful in that way, please let me know. It's
okay.
Often a role that CoLabs plays. We can perhaps speak up or make statements in ways that it's really just not,
Yeah, so what I'll do is we have a couple initiatives. So we have a congressional office in DC that I work very, very closely with.
Okay.
And I think what I'd do, if you're okay with it, is maybe I'd set up a meeting with yourself or whoever on your staff, my congressional office counterpart, and me to discuss that, because we're starting a series of conversations with Congress, and if you could help us, that would be very nice.
Okay, yes.
Yeah.
Let's plan to do that, and really as soon as that first week of December, if you'd like, just after the holiday
Yeah,
week.
after. Yeah.
That I'm trying to get a sense now from Representative Neguse's staff. There was the presidential election and overall election was just a big benchmark for them to say, going back in September even, they're like, we really don't have time to talk to you about much.
Yeah.
So we sort of see where things are going. And now with the senatorial election in Georgia, it's still a little unknown, but there's at least a big path switch, that they know that they can be going on. And that hopefully will inform some more of the legislation and policy that Representative Neguse, I know, wants to move ahead on.
That's
guessing
great.
Senator Hickenlooper may have the same type of enthusiasm for getting out in front or otherwise being seen as leading a couple topics of legislation. That's what I'm looking to get a sense of. No matter what level of, say, spotlighting or vanguarding a given senator wants to do, what work you're doing, all the federal labs, and then CoLabs as an advocate for you, just look to get the right information in their hands.
Yes, that would be terrific. We're in a unique spot as NTIA. We're very different than NIST, and so I hope to highlight that today a little bit for the Congress staff. But interesting note, I see you have Jung Yi Lee. So I came from Honeywell Quantum, and so that'll be very interesting to hear his talk.
Oh, okay. Yes. Great. Well, I'll see. So we're coming right up to time here.
Yeah.
I found people
do what you need to do. I'm just glad my system's working, because we have VPN security. I wasn't sure.
Oh, great. I'm just checking. Let's see. Let me just check down here and make sure there's not texts or last minute. Hey, I can't get in. Oh, there's Christine. Hello, Christine. Good morning.
Hi, Dan. How are you?
I was looking down at my phone to make sure that I wasn't getting any urgent texts or anything. Thank you for making some time. I would expect we will hear from June will get on the call, and his colleague, Dr. Stephen O'Neill, is going to join us as well. And good morning, June.
Hi, good morning.
Thank you for joining us there. Hello. Oh, I
Hi.
like your background.
That's a very nice background.
Yes, you have my home office, just closet and whiteboard is what you can see behind me. Thank you. Well,
so June, let me explain. I recently joined NTIA, but prior to that, I was at Honeywell Quantum. So we have a lot to talk about someday.
Yeah, that's excellent.
great.
Welcome.
And
All right.
yes,
Good morning.
very
Stephen.
familiar with Jilla and all the work you're doing there.
Yeah, the Honeywell hired
A lot of people.
29 of our students. I think 7 of my former PhD and postdocs are working there. I'm very proud of them, and thank you for support also working there, because it's impressive. You guys in 3 years build one of the best quantum machines.
Yes, it was very exciting, and we were glad to have such a great candidate pool, and really smart people, and nice too. Like really we're able to do a lot of things in under a very, very short time period, as you said, including building up two buildings of laboratories from nothing in 3 years. Yeah. It's great.
No. The CU, we are very proud of them. And actually, I think that's really one of the prime examples of the so-called quantum ecosystem.
Mm-hmm.
Great. Well, good morning. Hello, Steve. We're just waiting for Jill and Lisa from Representative Neguse's office to join us here. I haven't gotten any urgent text from them saying, something dramatic has happened. Sometimes that does happen, but I expect them to join on any moment now. And as you would have seen, I think I shared with each of you the invitation. Once this was fully confirmed, I just sent out a blast to the Collabs network, inviting anyone who would like to be in the audience to observe this. So I know there'll be some people who are part of the audience, but really our main focus will be the staff from Representative Neguse's office. Hello, Carissa.
Hi, how's it going?
Very good. We're still waiting for Jill to join in, and perhaps Lisa if they're able to.
Yeah, so Jill is going to run a little bit late, so I'm happy to share any context for the call, but she's going to be jumping on, I think, 15 minutes later. So.
Okay. Well, then let's get formally started, and we'll let her jump in. And the speakers here have prepared some short presentations and otherwise have some great information we want to make sure is on your radar. I'll hand this over to you in a second, Chris. You can describe your role on Representative Neguse's staff. But let me start with a little bit more of a formal welcome to the people who are in the audience. I'm Dan Powers, the Executive Director of Collabs, which is a nonprofit consortium here in Colorado of over 30 different federally funded research laboratories and joint research institutes. And our interest in nurturing this network of federal research labs is to ensure that they stay funded and stay here in Colorado. Part of how we do that is to share some of the most crucial research going on with realms of elected official and civic leaders, so they understand what's happening in the labs and how that information and research could be a resource for them, and also connecting these labs with technologists and economic development organizations and entrepreneurs and companies of all types, typically in some type of technology or engineering realm, so that partnerships and other ways of manifesting the science can get out into the quote real world. This kind of call is a way to put on the radar of, in this case, our Representative Joe Neguse from Congressional District 2 in Colorado, a couple topics that he had asked about that could serve his purposes for brainstorming on policy and legislation goals in 2021. I'll circle back around towards the end, but we do have Carissa Bungie from Representative Neguse's office here, and others may be joining from his staff. I'll turn it over to you, Carissa, to frame this even more pointedly if I just was vaguely implying there why we're on the call. Tell us again why you had asked for this call, and then we'll get into the presentations.
Yeah, thank you, Dan. So as Dan mentioned, I think first of all, thank you all for taking the time to do this. This is really helpful to us to stay in touch with what all of the wonderful labs are doing in the state and in the district. And really the why for this is that Congressman Neguse really cares about the research that's happening back home in Colorado, because there's so much great stuff and we just want to stay up to date. And we really want to prioritize supporting you all, whether that's through funding, whether that's through legislation, and also taking the best available science that we have and implementing it into policy. And with that, the 117th Congress is right around the corner. So we are thinking about what bills we're going to introduce. So we really want to make it a point to rely on the wealth of scientific knowledge that we have back in Colorado. So yeah, just really looking forward to all of your updates. And my role in the office, I'm in DC. I am the Congressman's legislative assistant. So I cover all of his environmental science, climate change policy work here in DC. And then Jill Grano, my colleague who is back in the district, should be joining in a bit.
Dan, you are muted.
Always getting caught on that. June, if you would like to start first, you and Stephen can unmute, and I believe you are given screen share capability here if there was any slides or things that you wanted to show as well.
I probably will show a few slides.
Okay.
Let's see. Hi, Carissa. Nice to meet you. So you can see my screens?
There we go. Yes, you are now in presentation mode.
Sounds good. And I'm going to actually turn on a little laser pointer even to be fancy.
Nice.
So I can tell you a little bit. I'm not sure if I actually prepared too many slides, but I think I have 7 minutes and I will try to be on time. Definitely want to be on time. But okay, well, sorry. This is not the first slide I want to show, but we can go backwards. Let's see. Well, I want to start with this quantum initiative that we have taken on the Colorado campus. But this is certainly Boulder and CU centric, but covers the whole state, definitely also covers the whole nation. And so it's very much relevant when we're talking about talking to a congressman and the staff members about this quantum initiative on the national scale that we build on a number of important pillars on science and technology, and to try to draw on, as you said, Carissa, the core strengths at CU Boulder and the surrounding institutions and the collaborating institutions to develop workforce, to develop technology translation, to accelerating commercialization of the core technologies and to build up the national competitiveness on the quantum. As you know, quantum technology is everywhere. I don't need to belabor the point. We use this every day. All of us are expert users of quantum technologies. But the point is that our modern society is built on quantum, and whether we realize this or not, but we are about to go on to yet another quantum revolution, which is based on more exotic features of quantum mechanics. Since we are Colorado, and since Dan gave us the mission that keep the jobs in Colorado, what's the best job in Colorado? It's a ski. And so you can think about a skier coming down, have some weird quantum superposition where he's going through the trees at both sides at the same time. It sounds very weird for classical people like us. But for quantum mechanics, these are what atoms and photons and molecules doing every single day. It's just very secretive. They are doing it in the microscopic world, usually hidden from us. But if we made our technologies right, we can actually show these quantumness of atoms and molecules every day. We're building quantum sensors based on this. It's like a magician that you can have a little magnet can be pointing up or pointing down simultaneously. A particle can exist in two different places simultaneously. All sounded very weird, but it's actually real. We actually make physical measurements based on these quantum mechanical principles called a superposition. And even more weirder, sort of a quantum element is this, if we have a pair of skiers and they become really entangled, And so what could be really weird is they are skiing on different slopes of the Vail Mountain. Somehow they can have this incredible entanglement that when she is skiing to the left of the tree, the man will always ski on the left of the tree without knowing. And if she is skiing on the right-hand side, he would be skiing on the right-hand side, and it's 100% correlated. That correlation is stronger than any classical possibility. And this is the quantum weirdness is called entanglement. In fact, it's so weird that Einstein never believed it to the day when he died. But experiments have proved him wrong. And this is where I didn't mean to show you math, but it's like this weirdness can be captured by if you 1 and 0s. These are we call it bits, except in quantum mechanics we call it qubit. And superposition just means you can be both up and down or 1 and 0 at the same time. And that already gives you this possibility of 300 atoms can store possibility of 2 raised to the power of 300, which is bigger than the number of particles we have in this universe. So you can see the powerfulness of if you can harness this power of quantum superposition and entanglement, meaning you can both on the same left-hand side or both on the same right-hand side, they're always correlated. And you can use this to control the quantum interactions, build gates for information processing. And this really is the 3 lines of math here really captures the whole quantum 2.0 revolution, the so-called quantum speed up, where you can apply these powerfully massive capacities of processing information, collecting informations for sensing, for communication, for computing. And that's what people have been talking about, quantum speed up, quantum power. And that's what's coming from. So I hope that I made that clear based on what we all love to do in Colorado, skiing. But there's a problem. How do we actually harness this? If you look into any of coming onto our labs, and that's what Dan was talking about, the technologies in Colorado, but it's complicated. And how do you really engineer such complexity, taking it out of the laboratory, building an actual real product? And that's really at the core of this challenge. How do you turn this technology into actual real economic gain? And so in Boulder, this so-called quantum center really is trying to harness, each particle is a magician's favorite object. And if you have to entangle all of these quantum objects together, it takes a lot of effort, from fundamental science to engineering to commercialization, quantum accelerator, and they all have to spin at the same time and being really supported at the same time, from fundamental science all the way out to applied science, applied engineering, and commercialization. So based on that, actually the Qubit, the quantum initiative at Boulder, we have taken on a number of these initiatives. We have got a quantum center funded by National Science Foundations called the Quantum System through Entangled Science and Engineering. We got another quantum center. We participate in a quantum center that's funded by DOE with the main headquarters at Lawrence Berkeley National Lab. It's called Quantum System Accelerator. And we have a nascent engineering center we are trying to build up called a Joint Quantum Engineering Initiative. And we have Quantum Forge, was devoted for workforce training and so on. So that's an ecosystem we are building. Actually, one good example I want to tell you a little bit is the NSF's founded center, which emphasizes on national collaborations among some of the leading quantum institutions led by Colorado. And we are collaborating with also National Institute of NIST and the national labs. And one of the main goals is actually training the quantum workforce for industry. And I think I'm going to stop here. This is actually a fine example. Just before you joined us, Carissa, that Cheryl and I were talking about, because Cheryl was actually from this company called Honeywell Quantum, and they hired 30 CU alumni, and they built a quantum machine from ground up in the past 3 years. So it's just amazing, kind of seeing the technology, some of the leading scientific work is being transferred into an industry and building a real machine. And that's all I have to say.
Okay. Thank you. Wow. All right. That is some provocative, and about 15 questions immediately come to mind on that. But In the spirit of this quick meeting for now, we'll move next on to we'll have Cheryl go, and then we will have some time for questions at the end, perhaps. But thank you very much. And hang in there, Steve. I can imagine you'll be asked to answer some questions as well. So Cheryl, over to you.
Well, hello. Thank you for your time. And I did provide Dan with some a PowerPoint slide sort of outlining what my laboratory does. But I want to point out to Carissa, and if Jill is on, the recent news about that the House unanimously passed the bill that supports domestic 5G market and open radio access networks. Carissa, I don't know if you're familiar with that or not. But that's a $750 million fund over the next 10 years. And I am NTIA's laboratory, and we are right in the middle of all of that. So we're very excited to help the nation roll out 5G. That is absolutely what we do every single day. So people get my lab confused very much with NIST. We are not NIST, okay? We're different. We're applied research. Although Zhongyi was right, I was the engineering director at Honeywell Quantum Solutions, and me and a series of other managers and directors hired something like 150 people, and produced from 10 people, produced the world's first trapped ion commercial quantum computer that has customers. And so why did I leave Honeywell Quantum? I left because at this point in my career, I want to do something for my nation, and NTIA and communications needs me right now. And so I left, and I left all of that excitement to generate more excitement for NTIA. So I'd like to just, I know that we have a very, very short time, but I want to just show one slide here. If this is, can you guys see my, let's see, share that. Can you see my PowerPoint slide? Okay, so just real quick, Carissa, the NTIA is the President's principal advisor on all telecom and information policy. Okay, what does ITS do? ITS is different than NIST. We are applied research, real world measurements, okay? NIST is long term. NIST has all those Nobel Prize physicists and with Jilla because they can fund, 20, 30 years of research. That's not what we do. We have a very much shorter horizon. We support the interagency, all of the federal systems, and we advanced communications technologies. We inform on all things spectrum. If you're familiar with all the spectrum auctions, that's us. That's what we do, and we investigate the most pressing challenges, ORAN, and this recent bill. So I just want to point this out to you. As a very important thing. If you're familiar with the wildfires that just happened last month, yeah, so we operate, NTIA operates the Advanced Communications Test Site out at Table Mountain. You see a little graphic there of where we're located. We were, at one point during the fire, we were in the mandatory evacuation zone, and it was frightening to hear the roar of the fire and to see it. That's just one picture. We have done a complete after action report and a complete safety recommendation to get a road that comes, if you can see, towards the east, towards the right-hand part of my screen, because the access road was very much in the fire zone and nearly consumed by fire. It was across the street, but had the winds not changed, we would not be able to get people out because there wasn't this easterly road. So with my colleagues, Carissa, perhaps through Dan's introduction or with you, or if Representative Neguse is interested, we could discuss with my colleagues in DC some of these findings from this very, very serious personal safety as well as equipment safety issue that just happened last month. And to me, safety is number one. It has to be when you're the director of a laboratory of so many people, and or even in your own personal life. And this was absolutely frightening. So I just wanted to share that particular piece with you. Thank the representative for his support in the ORAN bill. really important for us. And to point out a few other things that we have going on. We have this particular project is with NOAA, who's also has a footprint in Colorado, and that's out at our communications test site. So it's very cool. We are involved in mainly interference testing today with 5G. We're building up our 5G capability. The Senate Mark has given ITS a modicum, well, $3 million to build more 5G capability, and we'll be looking for more in the future. Finally, we are the government systems experts at ITS. That's again a differentiator for ITS, and we're those experts so that the interagency, all of the other agencies, don't have to have that expertise. So they come to us. We do projects with them, and finally, with our counterparts in NTIA and across the nation. I love that term. If you've heard it, Carissa, whole of nation. I love this term because that's what it is. And this space, communication space, is so giant, so many different ways to attack it and do research, applied research, which is what we do. But we've had serious wins, if you will, that added directly to the GDP of this country. So with that, I know we don't have much more time. Feel free to reach out, and I want to thank Dan and you for your time.
Great, thank you very much, Cheryl. As she mentioned, she shared the slides with me, and we'll be creating on Collabs' news site and throughout our social media, and also directly Carissa sending sort of a mini report with this information to yourself and Jill, Lisa, to your whole team. We'll just make this available. So typically beyond these conversations in the immediate live today, we end up discerning several other audiences and individuals who need to know about this, and we will make those efforts on our speaker's behalf. So,
thank you, Dan. Dan, the only thing is I don't know how to stop sharing.
Oh, okay.
Let's see.
Make that happen.
Okay.
Or otherwise, Christy can kind of take over, as it were. Let's see.
Okay.
I'm not sure I can. I think, Dan, you can stop Sherry's screen sharing. You are the host.
Let's
Yeah.
do that.
Oh, I found it. There it is.
Okay.
That's
Okay,
good.
we're good.
Okay.
All right.
All right. Over to you, Christine. And thanks. Already, my brain is full, and like the thought bubbles are. I'm jotting down a lot. When you see me looking to the side here, I'm not just checking YouTube or something. I'm taking a lot of notes. Thank you. All right, to you, Christine.
All right, great. Let me quickly. Okay, I think we're good. All right, so hello everyone. It is my pleasure to be here and briefly talk about ASPILE. So this is a newly funded NSF Engineering Research Center. This is on advancing sustainability through powered infrastructure for roadway electrification. So I'm Christine Lu from University of Colorado Boulder. So I'm the CU Boulder campus director for ASPILE, and also I lead the data research thrust within the center. So what does ASPILE want to do? So this is our vision and impact, right? So vision is really like we want to enable and explore all the possible ways to make it happen. It's about the widespread electrification of all vehicle classes. Okay, so we probably all know like the potential impact if we can make this happen. So that's really about reducing the greenhouse gas emissions, improve the air quality, right? And also reduce all the costs in terms of transportation when we're moving people and the goods, right? And also we do see great potential for increasing domestic job growth and also energy production. So how are we going to do this, right? So there has been a lot of effort already. And when we kind of started talking about it, so really think that there's important to kind of rethink the boundaries and the various industries that are related in this particular topic. So we want to start with, of course, user needs, right? That's the needs of our users need to moving like people and groups, right? So this is about individual users. This could be shared ride, and this could be like fleet operators, light duty to heavy duty, right? So it's really about for them making it convenient, right? And it's just kind of easy. So they don't have to constantly think about the range or the cost and where they're going to get charged if they are like using an electrical vehicle. And then this gets to the whole piece of the charging infrastructure, right? Think about like how you can charge when you're parked, how you charge when you're moving slowly. This is public like transit, or like there's kind of heavy kind of say like freeways where there's a lot of like heavy traffic, right? So they're just like how you get all these charging facilities working, both in terms of kind of stationary and in motion charging. And then of course the power grid, right? So this is where the energy comes in. So you really need to kind of integrate the utility side as well to like how they generate energy and how that will be like distributed, right, properly, giving all the dynamics of the spatial temporal variabilities. And then of course, our transportation infrastructure, right? Think about all the pavement, right? Because if you want to embed any charging capabilities in the road, and also like, of course, the various kind of like ways of traffic control, knowing that how people need to kind of charge or at different times. So that's really kind of ASPI comes in, is about kind of putting all this together, because we really think of a solution that really kind of makes this working is something that kind of connects all these boundaries, or we've been breaking those boundaries to kind of think together how we make this work. So like we think about, it's not just the physical infrastructure, but also it's about how we can have all this intelligence, right? So you want to have this the capabilities of being able to knowing what is happening, planning what is happening, and in real time making control decisions. So that's really like where we feel like this is the really timely and important that we have to do this now, because we already talking about the next decade or so, and this is the decision we need to figure out soon and actually have like much longer impact. So specifically, so ASPI really enables, of course, the technology development side, right? We are talking about how you can have all this cost-effective and seamless charging capabilities, right? This is really the whole infrastructure, not just say one charging station or one kind of like a charging pad you can put in the garage, that kind of thing, right? It's really about how the whole thing connects together. And really also think about the electric vehicles as a part of the grid resource, right? It's not just say like one stationary scenario, we're just kind of like pulling energy. We really think about how the utility of the grid, how the electric vehicles, and how the management decisions are made in this seamless fashion. And hopefully towards the end is a more sustainable solution, right? So it's kind of like seamlessly and more managed and much more efficient overall of infrastructure. And then big part is about the workforce development, right? If you look at the different kind of areas or different kind of industries we are talking about convergent research, right? This is not something that can be done by one piece or one sector of our community. It's really about how we take this systems approach, right? Incorporating all the different components, right? Think about how data science and adoption work closely with the power and the transportation side, because we are talking about how the whole system works, right? And then we also particularly focus on this kind of inclusive pathways, right? So this is actually a big part of the Gym for ERC is that we have the engineering workforce development, but also with diversity and cultural inclusion, right? We want to make sure that we're providing this diversified pathway, so people can, like we talk about pre-college education, we talk about the trades, right? And how people can get through the the various kind of like levels or different types of degrees, but still being able to explore their full potential within this kind of integrated capability. And then market development, right? So we are going really from fundamental research, connecting all the way to applied, actually to building kind of real world infrastructure. So we are trying to look at how one, of course, is the public literacy, right? We just want to, because this is not just like a small lab or a research community can do. It's really about the general public being more aware of the environmental, economical impact of our transportation sector and how the electrified transportation would have, right, on our society and the environment. But also there's a lot of kind of policy and funding situations, right? We are exploring like what kind of policy, what kind of decision making, right? So because all this needs to be policy scientifically grounded and also tied specifically to various real world usage scenarios. And then from the stakeholders' point of view, is really about how ASPI as a research center, right, can provide the technology kind of capabilities or the insights, the expertise, and also various case study tools and reports. That's really about kind of empowering the whole nation, and so that we can work on this jointly. So ASPI is funded as a 10-year center. So we start, of course, this big part as kind of like the initial kind of kickoff thing is the NSF like funding, right? So that's $50 over 10 years, okay? Also with like 8 million, $50 million over 10 years, and then the 8 million, that's the cost sharing part. But this is focused more on the kind of fundamental research side, right? But then like somewhere in between, it's more about, like, say we have the state funding. This is from Utah State in particular, and also we have memberships because we have our industry members, we have our innovation partners. So they also put in, as a part of the like the center, they put in the membership. Okay, but then there's a lot more kind of like going from the kind of convergent research, the fundamental one, to more the applied and the real world projects. So these are through kind of sponsored research with our federal agencies, but also a lot of kind of real world, like this public-private partnership projects. So we are planning for some kind of like over 200 million grants to support the various kind of types of activities. So very briefly, so this is actually a large effort, right? So it's led by Utah State. The PI actually got his PhD degree and was on the faculty at CU Boulder before kind of moving to USU. And then we have the core university. So Boulder is one of the core universities, and we have affiliated like faculty members. So from like within Colorado, we have Colorado like State University and also UCCS. So they are also part of this. And we have various national labs. So NREA, which is close by, also in Colorado, plus 3 other national labs. And then we have quite a few industry members and like innovation members. And we're actually continuously growing this joint effort because we really want to get like everybody like who is related to be part of this and be aware of what we're doing here. So that's a quick summary. So ASPI really aims to support sustainable and equitable transportation for everyone. And this is a big effort, and we're very excited to be part of this. Thank you.
Wonderful. Thank you, Christine.
Okay.
So I'd like to reference how I, with our panelists, I believe I had shared in advance, and also for our audience, so just put into the chat function, links to 2 particular committees that Representative Neguse is part of or had helped form. Carissa, I'd shared with the panelists both the, I don't want to say the name incorrectly here, so I'm looking at my screen, the Bipartisan Congressional Caucus on Innovation and Entrepreneurship that Representative Neguse formed earlier this spring with several other representatives. And that particularly has a goal as a caucus. If I can excerpt from the description here, they're looking for ways to, let's see, how the government can stimulate robust economic activity and growth by fostering conditions that support entrepreneurs and their efforts to obtain the resources needed to start and grow their companies when it comes into these realms of innovative technology of quantum or digital communication, and now electrification or otherwise advanced transit technologies. That is a caucus that we are hoping to have this information and research in Colorado be more on their radar. Of course, the research happening here in Colorado is an asset to the country, if not the world. So thank you to each of the panelists for providing that insight. There's also the other, and this may apply a bit more directly to what Christine was describing, the House Select Committee on the Climate Crisis that Representative Neguse is part of. Their report earlier this year laid out several thematic and specific policy goals to help address pollution reduction and otherwise address the climate crisis. So thank you. That's a bit of the broad scope politically around and policy-wise how this research we look to have it play a role and otherwise be a resource for our elected officials and decision makers. Carissa, could I turn this over to you now if you have questions? And then also I've prompt the panelists, they might each have heard things from each other that they would like to ask about afterwards. But Carissa, to you first.
Yeah, I mean, this is all fantastic. I'm just like blown away. Before I worked for the congressman, I worked in science communications. And so this just makes me so happy because, you know, the skiing metaphors, the clear graphics, like every part of all of this was great. So yeah, this is, I feel like I say this to Dan every time we have these calls. This is like my favorite part of my job. So yeah, I mean, I guess I don't know if I have like specific questions. One thing that popped out to me on 5G, are there still any issues with like spectrum allocation with 5G and like just sharing of spectrum? Like what is like the status of that? Because I worked at the American Geophysical Union before I worked for the congressman, and I remember that being an issue that we were engaged on. And so I'm just curious, like where that stands, because I haven't kept up.
Right. So the whole of nation has definitely allocated and shared set aside shared spectrum areas for 5G. We are looking right now at 6G. And so, this sweet spot from about 8 gigahertz to 24 gigahertz is really the next big shared spectrum area. There's that being said, 5G isn't even rolled out, but you asked specifically about the spectrum aspect. So within NTIA, there's the Office of Spectrum Management. And so ITS, the nation's Spectrum and Communications Lab, we work very closely with our sister organization at NTIA on all things spectrum. So if you look at those charts, you see spectrum sharing is not new. ITS has been decades and decades of sharing studies and data so that there's well-informed sharing regulations that are made. If you've heard about Legato, we were definitely involved with Legato. Actually, when I was in a past life, I won a gold medal for sort of my work analyzing that Legato band. But as recently as July, in this new role, my staff was involved with the Office of Spectrum Management, the DoD, FAA, other government agencies, and the recent FAA rulings in that band. So spectrum sharing, maybe 30 years ago, was with systems that were similar. And now spectrum sharing is increasingly systems that are dissimilar, LTE and radar. And so we're right in the middle of all of that.
Yeah, I don't envy anybody that has to deal with those conflicts, because that's tough.
Yeah. Here's the beauty is that being here at the Nation's Spectrum Communication Lab, what we do really, the White House will call, right? And so we really can have a scientific input to policy. And that's real powerful. Being part of a regulators, NTIA is the regulator, right? And it's great so my PhD is in electrical engineering. I am not an administrator, but I'm an electrical engineer through and through. That's why I was at Honeywell Quantum. But being able to say, we stand on this data, we have done this modeling, this analysis, this measurement, and this is what we recommend, and be listened to, that's the cool stuff. That's cool stuff.
Oh, and you may have bigger ears in 2021 listening to you as well. If I may say.
Okay.
So
thank you. That's really helpful.
But Carissa, I do want to make a push just for our safety issue. If there's anything we can do to get you, Dan, the congressman, together with my cohorts in DC to discuss that, it's very frightening, and we need help, because we have to cut in a road, and we have to have online gate access. We did a rough order magnitude estimate, $750,000, and we don't have it.
Mm-hmm. Gotcha.
So,
yeah,
just putting that out there.
Okay. Yeah, I'm more than happy to follow up with you and maybe schedule a call. We can talk about what the options.
Thank you.
Yeah.
And could I ask to Christine and to June and Steve, and each of you referenced in your presentations the workforce development aspect of the scope of all of your work. In the couple minutes we have left, I wonder if you could each describe a little bit more of what does that look like on campus, and in terms of the innovative partners that you might be working with. That notion of workforce development is definitely of interest across vast swaths of our political landscape. So please, describe more. Perhaps June, we'll go back to you first.
Okay, this workforce question actually goes, I also resonate with what Christine said. Remember when she emphasized on system design point of view, where the fundamental research and application engineers are going together. And I think the same thing Cheryl was emphasizing as well. Quantum, this is actually very important. We don't want to build a quantum machine in an academic institution without eyeing for application. So this workforce is actually very important to be able to go from fundamental science all the way to system engineering. Electrical engineers are tremendously valuable in quantum just because the system has to be engineered to a smaller version. So what we are seeing a little bit that we can gain more support, and I'm actually a federal employee, so I'm in principle cannot do any lobbying work because I'm not going to say anything about what we need, but maybe Steve can say something. What we actually are lacking right now is for workforce, what we want is to be able to train students with hands-on experience. That's what we hear from Honeywell, Quantum, and so on industry all the time is we need students who have been touched on some of your experimental magic. And you don't need a PhD, you just need 1 year in those quantum labs and then become really useful engineer. And we right now, on campus would benefit if we have some buildings that are dedicated to that kind of training and really allow us to, sit in between. We want to have a scalable workforce training program where you can have individual students working in my lab, but that scale is very small. If you just teach them with classes, that's scalable, but the impact is not as deep. What we need is somewhere in between. And that's really a new component we are designing for quantum, among many other components. But that's one thing that I want to emphasize. We call it quantum forge. And this is something that maybe, Steve, do you want to add a sentence or two on that?
Yes, this is the quantum forge is the component that is probably has one of the highest profiles within our QLCI proposal, and is designed to sit between some sort of senior demonstration project where you all know the result going in. You just have to demonstrate it on the one hand, and just dropping a senior undergraduate into Jun's lab and have that person just be stunned for 6 months and then come up to speed. And what we're after is something where the student in engineering or physics or chemistry, whatever, can stub the toes and burn the fingers on apparatus and tools and techniques that person will need when they're an entry-level person into industry. Companies we've talked to are tremendously enthusiastic about this. Folks on campus are tremendously enthusiastic about it. To touch on some of things that Jun could not say, but sort of did, what we miss is a dedicated space of the right preparation and quality to really house something that ambitious. And we are struggling a little bit to find out how do you inject financial resources into that, and how do you manage it so that the companies who are tremendously interested in the prospects can participate in the projects and maybe take on these quantum forgees as interns during the summer and influence the quantum forge by helping us select what actual projects they work on, not demonstration projects, demonstrate the charge of the electron, and not cutting edge research projects, find the dipole moment of the electron, but somewhere in between. And I think this is a tremendously exciting frontier, founded, as Jun hinted, by research that one of our QLCI investigators has done. It's Heather Lewandowski, Professor Heather Lewandowski. This is part of her research. What do companies want from their undergraduate and master's level graduates? And that was really what was behind Forge. As we get this up to speed, I think this is going to be a nice model that we can export to other organizations wherever.
Yeah, that's really interesting. I'm curious to learn more about that and what legislatively we could do to support that, whether that's directing agencies to collaborate with companies about like what they need to fix in terms of the pipeline of getting students into that workforce. And like you said, kind of making that, scaling that the right way. I'm just curious, definitely curious to learn more. So.
Okay, we can follow up.
All right. Yes, and then Christine will give you the last word as we're up to time, but describe some of the workforce development and impacts that you perceive with Aspire.
Yes, thank you. I want to quickly read this slide. So we don't need to read the details, but I think that the key concept here is that we take a very diverse pathway through this. It's not like within the center, we have one standard pipeline for everybody to follow through. We know that people can come in from different points, and then they may leave at a different point, but they take a very different kind of like pathways through this. But the idea is really about kind of convergent. So that means we want to get people who have very different backgrounds, right? Very diverse backgrounds, but then be able to kind of go through this in some way that was suitable for their setting. So think about like pre-college setting, right? So this may be students in kind of rural communities or lower income communities. If they are not part of this, we may not have enough, how to say, focus on, say, the underdeveloped areas, or like say we will be just building this infrastructure for the urban area. That is really not good, right? Also think about the workforce, like working professionals. They are already like think about construction, like engineers, right? So they need to learn this, but then they maybe say they may have some trade school capability, or they come in for certificate, and also by working with our students, right? So that's also kind of more direct interaction. So this is really connecting students at very different like stages of their career, but also with working professionals through our partnerships with both industry members, innovation members. I really want to kind of emphasize really about this diverse pathway that really kind of aims to connect like the various stakeholders at very different stages. All right, sorry. Okay.
Oh, I love that graphic.
A very clever and savvy graphic there. Thank you. So, as I mentioned, Cheryl had sent in the slides that she had shown before. If June and Christine, if you'd like to share those slides with me, I'll compile that into a program, a document for Representative Neguse, but also for some others. And thank you. Then we're up to time. Meant to make these a very quick, get some ideas and contacts and faces with the names onto people's radar, and then further conversations can be born of this quick conversation today. Thank you all for your time, and thanks for making time for us, Carissa. We'll share this information with your team. And otherwise, thank you everyone on behalf of CoLabs for the work that you do. We have a vision of science being admired and recognized as the pursuit of truth, if I can speak personally, and then using that as a guiding force in our decisions to make humanity's experience on the planet better and safer and more resilient and enlightened. So thanks. You all are involved in that realm of providing the kind of information that we need for teams like Carissa and Representative Neguse to then take into the political decision-making process. This is important, and really appreciate it. I look forward to following up with you each afterwards. This was some great information. But
thank you for organizing, Dan.
Yeah, thank you.
Thank you so much. Really appreciate it.
I'll be in touch.
Thank you, everyone.
Thanks. Bye.